Hello, welcome to Maths again. Today we are going to talk about logarithms. Remember that logarithms are to calculate exponents for a certain base, all right, and to obtain a result. So imagine that I have logarithm base A of B equals C, all right? This number is the base of the logarithm, the number we write here. Then this will be the exponent so that I obtain B, this number, okay? So I can transform this into a power. A to the power of C equals B. I'm looking for an exponent for A so that I obtain B. So we are calculating exponent. The result of the logarithm is the exponent I need for the base to obtain this. Is it clear? I hope so. There are certain conditions when we are defining a logarithm. The base A must be greater than 0, must be positive, and it must be different to 1, all right? Because if I'm looking for exponent to number 1 to obtain any other numbers, that's impossible because 1 to any power will be always 1, all right? And the number that we are calculating the logarithm must be positive, all right? So I must follow these conditions when working with logarithms, all right? There are two bases that are very important. One of this is when I'm using base 10, I don't write it. So for example, if I write logarithm of 2, I mean that the base is 10 and I don't need to write it. This is a common logarithm. So if we don't have no base, we have to know that the base equals 10. All right, you can calculate this easily with a calculator. You have a logarithm button, so you press it and then 2 and you obtain the result, okay? This is a common logarithm. Then we have the natural logarithm. A natural logarithm, the base equals e, the irrational number e. Okay, so we write it with a capital letter L and then an N. Natural logarithm of, for example, 2. You can solve this with your calculator easily as well. All right, let's solve some easy examples. Imagine we are calculating common logarithm of 100. What do you think will be the result? We are looking for an exponent for number 10, that is the base, so that I obtain 100. So 10 to the power of 2 equals 100. Another example, logarithm of 0.1. I'm looking for an exponent to base 10 so that I obtain this. So the result would be -1. Now imagine I'm calculating natural logarithm. Now we use base e of e. What exponent do I need for number e so I obtain e? It is clear that it would be 1. And if I calculate in this, what exponent do I need for e so I obtain e cubed? The result, it is 3. Another important point is that exponential function and logarithm function are inverse, all right? Remember that exponential function is something like this, okay? And then we have the logarithm. So if I input x in an exponential function, I will obtain y, the output, all right? And if I perform logarithm base a of y, I obtain x again. All right, so exponential function and logarithmic function are inverse. All right? So if I perform one and then the other, I arrive to the same place again. All right? So let's check that this is true. For example, if I do logarithm, first I perform logarithm. First I perform exponential. This would be the exponential function. And then I put it inside a logarithm. What would be the result of this? What exponent do I need for this base so I obtain this? It is clearly x. So when applying first exponential and then the logarithm, I arrive to the same place as I started, all right? And if I apply first logarithm and then exponential, right, I raise a to this, I will come back to x because, look, logarithm a, base a of x equals, for example, y. So the result of this, the logarithm, is the exponent I need to obtain, the exponent I need for base a to obtain x. So if I raise this to this exponent, obviously I will obtain x. All right? I think this is a good introduction for logarithms. Now you're ready to work with them. I hope so. Bye, see you soon.